Okay, actually today we will continue with the past papers questions from space physics. Last time, like in this group class, we practiced some questions from space physics, and today we will continue with the rest of the questions from space physics because there are very few questions, limited questions in space physics. Question number 9 is the planet Venus orbits the sun at a constant speed of. So speed is given 3.5 exponent 4 meter per second, and it takes a time TV to complete one orbit. So basically the time required for one complete orbit is TV, and this is the speed of the body through which it is moving. Okay. Now in part A, Venus is always 1.1 exponent 11 meters from the sun. So this is the distance of the Venus from the sun. And now we have to find out this time. So basically distance is given like the radius, and then we have speed. I will upload this file in the same link after the class. So you may download the same file and you will get all the solutions same like. Okay, so now we have to find out the time, and we know there is only one formula, that is the time for the speed of the orbits of the planets or the orbital speed. So from that formula we can calculate. This is the formula 2 pi r over t, or tv is equals to 2 pi, distance is equals to 1.1. So this is the formula, right? You are getting answer to exponent 7, right? So time is seconds. Okay, so in the first part, we calculated the time period. In the second part, we have to explain why speed is a scalar quantity. So this is also a very simple, because a scalar quantity does not have direction. And velocity is a vector quantity. So explain what happens to the velocity of Venus as it orbits the sun. We know that velocity is a vector quantity and it also includes direction. And when Venus starts to orbit around the sun, so definitely direction changes. So when direction changes, so definitely velocity also changes. So basically velocity changes. And
The direction of what you call Venus changes.
yes, and reason is very simple because
The direction of Venus is changing constantly.
movement of Venus in its orbit is changing. And there is a resultant force on Venus. As it orbits the sun force is perpendicular to the direction of motion. So state why this force is needed. So basically, this force is the force for the circular motion, and we know that in circular motion we required a force to keep the body in a circular path, right? So to keep the body in a circular path, we required some force, and that force is called centripetal. And same force is required over here in the motion of the Venus in the orbit around the sun. So you can write that this force is required to keep body in a circular path or in an orbit to provide a circular motion. Yes, you can also write that to provide a circular motion to the planet in the universe. Sorry, around the sun. And in part 3, figure 9.1 shows the orbit of a Venus around the sun. On figure 9.1, draw an arrow to show the resultant force on Venus. So in this diagram, we only need to draw an arrow to show the direction of resultant force on Venus. So we know that it always towards the center of the circle, right? So this is the direction of the force, right? And in
So I
part,
have a question.
hmm,
How do you draw such straight lines on laptop?
basically now it is like after practicing date on daily basis, I used to write so many times, so that's why it is easy for me to draw.
Okay, okay, okay.
And in part 4, state what causes the force acting on Venus. So basically, we know there are only two planets, and in planets we have gravitational force, or due to the gravitational fields, there is a force of gravity, gravitational attraction of sun. So there are many ways to write this answer also. Gravitational field of sun provides force of attraction. Okay, one planet in solar system is close to the sun, then Venus. State the name of this planet. So for this, you need to know about the sequence of the planets in the solar system like Mercury, Venus, Earth, Mars, Jupiter. So Mercury is the first planet that is the closest to the sun as compared to the all other. So Mercury. And in part 2, compare the time that this planet takes to complete one orbit of the sun with the time and explain the difference. So basically, in the first part, we calculated the time that is taken by the Venus to complete its orbit. Okay, so in this part of this question, they are asking that you have to compare the time that is taken by this Mercury planet as compared to the time that is taken by the planet Venus. So which time period will be greater or which time period will be shorter? Because Mercury is close to the sun. right? So when Mercury is closer to the sun, so definitely orbit is also small. Let's suppose if this is sun, so Mercury, this is the radius of Mercury, and Venus is the second planet. So the radius of Mercury is less than the radius of Venus. And according to the formula of orbital speed, time taken is less as circumference of orbit is smaller, right? And you can also relate with the help of formula V is equals to 2 pi r over t. So from this formula, you can also relate that the time taken is less than the time taken by Venus, because the length of circumference Okay, so basically, this is another question. Question number 10. So astronomical distances are measured in light years. We know that we are not able to measure distance in meters, kilometers in space. So we use like from one point we just strikes the light, and that light will travel from that point to the other point where we are observing that light. So that will give you the time that how long light takes to travel that distance, because the speed of light is constant in vacuum, and with the help of the speed of light we can find out the distance traveled between 2 points. And in first part, they are asking the same, the definition of light year. So light year is like the distance traveled by a light in 1 year is called light year. So there is a fixed value that light will take this much time to cover this distance in 1 year. So we measure the distances of other planets with some other planets with the reference of light year, that from one planet to another it will take 3 light years. It means this value will be equals to 3 times the value of 1 light year. The sun is one star in the Milky Way galaxy, and state the approximate diameter of the Milky Way galaxy. Because we know that,
100,000.
yes, right. We are living in one galaxy, and that galaxy is the part of the universe also. There are so many galaxies, other galaxies are also available. So our solar system, like present in this Milky Way galaxy, and the value of diameter is right. You mentioned 100,000. So that is the value for the diameter. So we can see that this is the diameter of our galaxy. It will take 100,000 years to travel light from center to uh, the corner or the edge of that galaxy. In part B, there are several stages in the life cycle of a star. So again, this is a question related to the life cycle. And you have to complete the figure. Names are given that a massive star goes through after it has used up most of hydrogen at the center of the star. So it is like it started from massive star, much larger than our sun. Then it converts into red giant. And after red giant, what is the next step? We know it is not red.
Supernova.
Yes, because it is already mentioned red supergiant, so it means red giant is not the part. White dwarf, neutron star, these are the last stage. So it is supernova.
And then nebula and neutron.
Nebula and black hole or neutron star.
Nebula?
Basically, this also takes place after the supernova because after supernova it starts to like uh, explodes the upper part or the upper surface of that star, and it starts to like explode the upper area or the upper surface because gravity is greater, so gravity starts to like consume everything towards the center, so the upper part of that star starts to explode, and that will converts into again dust and star particles, so that becomes nebula. Basic
Oh, okay.
Yes, these explanation are already given in the notes of that life cycle of a star. So you may also take reference from there. What are the stages and how we explain those stages? So you can see in red giant, planetary nebula, white dwarf, black dwarf. So in this way, it starts to convert the state of the star and state the stage in a life cycle of a star where heavy elements are formed. So this is also supernova. In some other paper, they also ask about the same part, but in different way. They ask like when we have again dust particles, gas particles. So what is the stage of that star? So that is also called supernova because it consists of heavy elements. Okay, so in part C, current scientific understanding is that the universe began 14 billion years ago. Okay, so in part C, from study, it is mentioned like universe began 14 billion years ago in an event called Big Bang. So explain one observation that supports the Big Bang theory. So we already discussed evidences about the Big Bang theory. There are two evidence, two observation. What are those? One is the redshift. So we can explain the concept of the Big Bang with the help of redshift, right? And then the explanation of it. Otherwise, you can also explain with the reference of cosmic microwave background radiations. So these are two references. We already explained somewhere. Okay, so you mentioned about redshift at the start of the universe. Radiation was emitted, universe expand, radiation from early universe. Examine now has moved into the microwave region and redshifted, right? So basically, if we start explanation with the concept of the redshift, so galaxies are moving away from other, and the wavelength is increasing. And increasing wavelength, red region, all spectral line, shifted towards the red region. All the spectral lines or all the wavelengths are red shifted. And it is also the evidence. Expansion of universe. So this is the idea. Or you can also explain from the second reference from like CMBR that initially that astronauts finds the sample so that lies in the microwave region. So that's why the second part is also that CMBR is also the evidence for the Big Bang theory. Okay, question number 11 is related to the planets. You can see in table details are given, and these are the details about 8 planets in solar system and their average distances from the sun, their orbital period, and their average surface temperature are given. So 3 names are missing, and we know the sequence. First one is Mercury.
Mercury, Jupiter, and Uranus, I think.
Yes. So in the first part, we just added up the names. And in part B, calculate the orbital speed. Okay, so basically now we have to find out the orbital speed of the Mars. So for Mars, we already have distance in kilometers. Distance is given, orbital time is given, and we have to find out the speed. So formula is distance is already given in kilometers, so we don't need to convert anything. Time is already given in seconds, 5.9 exponent 7. And in C part, we have to describe the relation between the distance of a planet from the sun and its orbital speed. So this is like a same repeated type concept in the just like the previous question of Mercury and Venus. So if we increase the distance, so what happens with the orbital time period? So if we are moving away from the sun, so orbital time starts to increase, right? Distance of planet from the sun increases, its orbital time period. Yes, they are directly linked. As the distance from increases, the orbital period in part D, describe the relationship between the distance from the sun and the average surface temperature of a planet. Because in our table, temperature is already given, right? So if we compare distance with their average surface temperature, so these are all the values with their temperature. So we can see that from Mercury till Neptune, distance is increasing and temperature is decreasing, right? It starts from 167, it ends up at minus 200, right? So as far as we move away from the sun, the planets gets colder as compared to the first one. Planets further away from the sun, the cooler the planet is. And one more thing, as you observe in the table, that Venus is more hotter than the Mercury. So the temperature of Venus is greater than the Mercury. So this is like a different difference in the temperature as compared to the normal sequence of the table. So Venus is more hotter than Mercury, or you can also say that Mercury is like cold as compared to the Venus. So this is the concept that we observe from this table. Otherwise, for all other planets, temperature is decreasing. Okay, in this question, now we have to complete the sentences about the life cycle of the star. So this is again a question related to the life cycle of the star. So protostars are formed from. So protostars are formed from the clouds of. So this is the formation of the protostar. And a protostar becomes a stable star when we know that when two forces are equal and opposite, like the force of
Wait, so I
gravity.
have a question.
Yes,
Aren't protostars formed from nebulas?
protostars.
Yeah.
Yes, you can also write it is formed like from nebula, or you can also just explain in detail like it is made up of clouds and dust. Because we know that when we have clouds of dust and gas, so it will definitely make nebula. So you will get marks in both.
Ah, okay.
If you only write nebula, so you will also get marks for it. And if you are writing clouds of gas and dust, so you will also get answer for this. So in B part, a protostars become stable. We know that it is already hint is given in the question is balanced by. So if nobody's know that how to answer this question, so you will get automatically a hint if you study about this topic. So there is a concept of the balance of two forces. So basically the gravitational force is in acting inward and it is balanced by the force due to the high temperature in outward direction. So inward force of gravitational attraction is balanced by the outward force of or outward force due to high temperature Right. And the initial fuel used to power nuclear reaction in a star is, so what is the name of the initial
Hyd
yes, so initially it is a start from hydrogen and it converts into helium. And D part, stars that are approximately the same size as the sun becomes red giant, which then form a
planet
planetary nebula.
planetary
Yes. Okay, so in the same way, we have different question, but mostly they are asking the same thing. Like, you will get question either from the average orbital speed, or you will get some values from the table, and they used to write name of any planet in any sense. They will ask about the table, and secondly, they will ask about like link between two quantities from the table, just like in the previous question we did. And otherwise they will ask about the life cycle of a star in any form that it will convert into this or that. So these are the concept linked in the questions of space physics from the past papers and some specimen papers till now, right?